Good morning, everyone. My name is P. Vanitha, working as Assistant Professor in the Department of Electrical and Electronics Engineering. I am going to present about solar energy, particularly focusing on solar thermal power plants and different types of solar collectors. This topic comes under the subject Power Electronics for Renewable Energy Systems. In this presentation, we will understand how solar energy is converted into usable power and study the major types of collectors used in solar thermal systems. Solar energy is one of the most important renewable energy sources available on Earth. It comes directly from the sun in the form of radiation and can be converted into heat or electricity. In a solar thermal power plant, solar radiation is first collected and concentrated using solar collectors. This heat energy is then used to produce steam or heat or working fluid. The heated fluid drives a turbine connected to a generator which produces electricity. So the overall process involves collection of solar energy, conversion into heat and generation of electrical power. Solar collectors are devices that capture solar radiation and convert it into thermal energy. There are mainly two categories: flat plate collectors, concentrated solar power collectors. Flat plate collectors are simpler and are used for low temperature applications. Concentrated solar collectors are used when high temperatures are required. Examples: parabolic truck collectors, parabolic disc collectors, solar power tower, Fresnel reflector. Each type works differently depending on the temperature requirement and applications. So a flat plate collector is the most common type of solar thermal collector. It is mainly used when the required temperature is below 90 degrees Celsius. The absorber plate inside the collector is usually coated with materials such as black chrome, black nickel, black copper. These coatings help absorb maximum solar radiation. Flat plate collectors are commonly used for solar water heating systems and domestic applications. The flat plate collector consists of several important components. First, there is a transparent cover, usually made up of glass or plastic. This cover allows sunlight to enter but prevents heat from escaping. Next is the absorber plate, which is typically made of copper, aluminum or steel. This plate absorbs the solar radiation and converts it into heat. Attached to the absorber plate are tubes or channels through which water or air flows. Cold water enters from the bottom, gets heated while flowing through the tubes, and finally moves to the storage tank. This simple mechanism helps convert solar radiation into usable thermal energy. To minimize heat loss, thermal insulation is provided at the back and sides of the collector. The insulation thickness is usually 5 to 10 centimeters. Common insulating materials include fiberglass, styrofoam. The collector is also enclosed in a protecting casing which protects the components from environmental conditions like rain, wind and dust. This insulation helps maintain efficiency by reducing heat losses. In addition to heating water, flat plate collectors can also be used for power generation systems. In such systems, the heat collected by the flat plate collector is transferred to a working fluid through the heat exchanger. The heated fluid then helps produce vapor that drives a turbine. The turbine rotates a generator which produces electrical energy. In this system, the flat plate collector heats water up to around 70 degrees Celsius. This heat is transferred to another working fluid such as butane, which has a very low boiling point of around minus 1 degree Celsius. Because of this low boiling point, butane easily converts into vapor when heated. The butane vapor drives a turbine, it producing mechanical energy. This mechanical energy rotates a generator to produce electricity. After leaving the turbine, the vapor is condensed back into liquid form into liquid form in a condenser and pumped back to the system again. One major uh, one major advantage of flat plate collectors is that they can absorb both direct and diffused solar radiation. In solar thermal systems, the process can be divided into three stages. First is conversion, where solar radiation is converted into heat energy. Second is production, where this heat energy is used to produce steam or drive turbines to generate electricity. Third is storage, where excess thermal energy is stored for later use, ensuring continuous power supply even when sunlight is not available. Next one is the parabolic trough solar collector, or PTSC, is a type of concentrated solar collector. It uses parabolic shaped reflective surface to concentrate sunlight onto a receiver tube placed at the focal line. The receiver tube is usually coated with a selective absorber material and covered with a glass tube to reduce heat loss. Concentrated sunlight heats the fluid inside the tube to temperatures between 250 degrees Celsius and 500 degrees Celsius. This hot fluid is then used to generate steam and drive turbines for electricity generations. Next one is the working of parabolic trough systems. The receiver surface has a special coating that absorbs solar radiation efficiently while minimizing heat loss. The working fluid flows through the receiver and gets heated to a high temperature. Uh, the hot fluid is then sent to a heat engine or steam generator which produces steam. This steam rotates a turbine connected to a generator producing electricity. Currently, PTSC technology is widely used in solar thermal power plants because it is reliable and well developed. The another type of concentrator collector is the parabolic disc concentrator. This system uses a dish-shaped mirror that focuses sunlight into a single focal point. Because all the sunlight is concentrated at one point, it can produce very high temperatures. The working fluid located at the focal point absorbs this heat and transfers it into a heat engine. The heat engine then drives a turbine to generate electricity. An important feature of this system is the sun tracking mechanism, which constantly aligns the dish with the sun to maximize energy collection. The solar power tower, also called the center receiver system, is another large scale solar thermal technology. In this system, uh, thousands of mirrors called helitostats are placed around a tall tower. Each helitostat tracks the sun and reflects sunlight toward a receiver located at the top of the tower. The concentrated sunlight heats the working fluid flowing inside pipes in the receiver. The working fluid may be water, molten salt, or liquid sodium, depending on the system design. In this diagram, we can see the working of a solar power tower system. First, sunlight falls on many mirrors called helitostats. These mirrors are placed on the ground and they continuously track the sun. Their job is to reflect and concentrate the sunlight toward a central receiver located at the top of the tower. When the concentrated solar radiation reaches the receiver, it heats a working fluid, usually water, oil, or molten salt. This heated fluid then flows through pipes and is used to produce steam. The steam is directed to a steam turbine which rotates due to the high pressure steam. The turbine is connected to a generator which converts the mechanical energy into electrical energy. After passing through the turbine, the steam enters a condenser where cooling water removes the heat and converts the steam back into the water. The water is then pumped back again to the receiver using a pump, forming continuous cycle. In this system, we also have thermal storage, which stores heat energy so that electricity can still be generated even when sunlight is temporarily unavailable. So overall, the solar power tower system concentrates sunlight, produces steam, drives a turbine, and generates electricity. This diagram shows the molten salt solar power tower system. First, mirrors called calithostats. That mirror calithostat reflects sunlight toward the receiver on top of the tower. The concentrated sunlight heats the molten salt, which acts as a heat transfer and storage medium. The hot molten salt is stored in thermal storage tanks and then sent to the steam generation system, where its heat converts water into steam. The high pressure steam drives the steam turbine, which rotates the generator to produce electricity. After the turbine, the steam goes to the condenser, where it cools and turns back into water and the cycle repeats. The molten salt allows thermal energy storage, so power can be generated even where sunlight is not available. In an advanced solar tower system, molten salt is often used to store and transport heat. The hot molten salt flows to a heat exchanger where it transfers heat to water to produce steam. The steam temperature may reach around 500 degrees Celsius with pressure close to 100 atmospheres. The high temperature steam drives a high pressure turbine generating mechanical power. The exhaust steam is reheated and used again in a low pressure turbine, improving overall efficiency. To conclude, solar thermal power plants convert sunlight into heat and then into electricity. Different collectors such as flat plate collectors, collectors, parabolic dish systems and solar power towers are used depending on temperature requirements. Among these technologies, concentrated solar power systems are widely used for large-scale electricity generation. Solar energy is a clean, renewable, and sustainable source that plays a crucial role in the future of global energy production. Thank you.